Our scale sample is about 0.02 to 0.08% in concentration. And to determine the exact concentration of that sample, we need standard solutions in that range. 0.02% is not a lot, and in order to improve our accuracy, we work with a 1% iron oxide solution and dilute it down to a range between 0.02 and 0.08. This is how the dilution works. We pour some of the 1% iron oxide solution into a glass beaker and then condition a burette. For that, the burette has to be completely filled with the 1% iron oxide solution, and all that solution gets subsequently discarded into a waste beaker. Now the burette is conditioned and we can fill some new standard 1% iron oxide solution into the burette. Should there be some air bubbles in the tip of the burette, we turn the stopcock, release some solution until the tip of the burette is bubble-free. Now we record the initial volume of the solution in our burette, and it does not have to be exactly 0. It can be at some level inside the burette to start our dilution process. We start in this example with 16.55 milliliters, and to get a 0.02% solution from our 1% standard, we need to release 2 milliliters into a 100 milliliter flask. So we place that flask under the burette and release 2 milliliters. And towards the end of this volume, we have to be really careful and slowly, drop by drop, approach the final reading, which in this case needs to be 18.55 milliliters. Now we fill up those 2 milliliters in the 100 milliliter volumetric flask with distilled water. First we use a water bottle and swirl, of course, intermittently. And for the last drops, to reach the calibration line, we use a glass pipette. See, in this example, we needed one more drop to be in line where our lower meniscus is in line with the calibration line. And we do that 3 more times with 4, 6, and 8 milliliters of the standard 1% solution until we have our 4 standard solutions for the analysis. The instrument for our analysis is a spectrophotometer. Inside a spectrophotometer is a prism that allows us to select a specific wavelength of light that gets directed through our sample. For that, the sample has to be inside a cuvette. Here you see some cuvettes, and it is important throughout this experiment that we never confuse the cuvettes and clearly assign which cuvette contains which of the samples. And even a paper towel can help us to stay organized throughout this lab. You push the on button at the back of the spectrophotometer and it will take a couple of seconds to warm up. After the instrument has completed the initializing process, we end up with the home menu, and the Spec 200 modern interface is the function we want for our experiment, and we confirm that by pressing the enter button, which is the round button there in the center of your up, down, left, right arrows. This switches the screen to a live display screen showing the measurement mode, and ABS stands for absorption. That happens to be the mode we want, but we want a specific wavelength, measurement wavelength, and for that is a round button on top of on the front panel, and with that round button we change the wavelength to the desired wavelength. In our case it has to be 390 nanometer. Once we have gone down to 390, we push that wavelength button and that locks in the wavelength for our measurement. Pushing the on button on the right again initializes our instrument It is now ready to measure the absorption at 390 nanometers. So we can now enter a sample if we like. The cuvettes have two clear sides and two frosted sides. One of the clear sides has an arrow on it. We fill the cuvette for the blank sample with distilled water using a glass pipette, about 3/4 of its total volume. Wipe the clear sides of the cuvette with some Kim wipe and place the cuvette into the cuvette holder of the spectrophotometer so that the path of the light passes through the clear sides of the cuvette. The display shows that the cuvette and distilled water absorb some of the incoming light, so we zero it in order to account for the absorbance coming from the cuvette and the distilled water. Using a clean glass pipette, we now fill the second cuvette with a 0.02% standard solution, place that into the spectrophotometer and record the resulting absorbance. Using clean pipettes and clean cuvettes, we determine the absorbance of the other three standard solutions and of our unknown sample. On the shelf of your lab bench is a beaker for the used cuvettes and pipettes. You place the suction bulb beside them and then empty the burette into a waste beaker and rinse it with plenty of distilled water. Take all containers that have liquids in them to the sink, wipe down your burette and the spectrophotometer surface, and then you're free to go. Not before washing your hands, of course.